আসসালামু আলাইকুম ওয়া রাহমাতুল্লাহি ওয়া বারাকাতুহু।
ওয়ালাইকুম আসসালাম।
সমস্যা নাই। আমাদের গ্রুপের সবাই একদিন দেখা করতে চাইছিলাম, কারণ রিনু ভাইকেও সাথে পরিচয় নাই, তারপরে মুন্সি ভাইয়ের সাথে পরিচয় নাই।
আহ, আপনার কোথায় থাকেন? আমি তো থাকি উড।
আপনার আমরা থাকি হচ্ছে জামাইকাতে, মুন্সি ভাই কোথায় থাকে? মুন্সি ভাই মনে
মুন্সি
হয় না।
ভাই থাকে ব্রঞ্চে, এই যে মুন্সি ভাই
ও
জয়েন করছে।
ও আচ্ছা।
আমি আর ওপেনিংয়ের কাছাকাছি, বেশি দূর না।
শাহিদ ভাইরা আমার কাছেই থাকে, খুব দূরে থাকে না।
জি
জ্যামাইকা তো গ্র্যান্ড সেন্টারে উঠলেই 10 মিনিট।
জি। রাব্বানি ভাই কোথায় থাকেন?
আমি একবারে কুইন্স ব্রিজের গেটে থাকি,
কুইন্স ব্রিজের, ও আচ্ছা।
ফ্রেন্সে।
আমি ওই বাসায় আগে থাকতাম, তার অপোজিট পাশে থাকতাম ওপেন ভাই। তার ওই যে আপনি থাকেন তার বুড়ি পাশে থাকেন না?
জি।
তো একদিন আসলে একটু ফেস টু ফেস হইতে পারলে এটাও ভালো আমাদের জন্য, তাহলে আসলে কি ইন্টারাকশনটা করতে আরো সহজ হয়। এখন তো খালি ভোকালে চিনি সবাইকে।
তা সত্যি, তা সত্যি।
ফেস টু ফেস যদি একদিন সময় করা যায়, মনে হয় যে এটা ভালো হইতো আমাদের জন্য।
ইনশাআল্লাহ
দেখা হলো।
হবে, দেখি একটা টাইম করে।
হ্যাঁ, ওপেনিং ভাই একটু টাইম করে চাটা খায়, ওই যে একটু মোটামুটি নিয়ে বসলাম।
আমি
হ্যাঁ
জ্যামাইকা
বলেন
যেতে চাচ্ছি,
কোথায়।
কিন্তু যাবো যাবো করে টাইম ফিক্সড করতে হবে।
জামাইকায় চলেন
ওকে
যাই।
গাইস, আমাদের হাসানকে যোগ দিছে?
না, 5 মিনিটের মধ্যে জয়েন করবে উনি।
ওকে।
আসসালামু আলাইকুম।
ওয়ালাইকুম আসসালাম। ভালো আছেন
ভালো
ভাই?
আছেন?
হুম।
আছি আলহামদুলিল্লাহ।
ওকে। আপনাদের পড়াশোনা কেমন চলতেছে?
কিন্তু ভাইয়া এই রিলেটেড একটা প্রশ্ন ছিল। সেটা হচ্ছে যে আমরা যে শিখতেছি, ধরেন পাইথনটা তো আমরা যে শিখছি, আমরা এই রিভিশনটা কিভাবে ই করব?
মানে কি, আমার কাছে ক্লিয়ার না।
প্রশ্নটা হচ্ছে যে মানে রিভিশনটা জাস্ট রাহাত ভাই যেটা করছে ওগুলোই, ওই সেম জিনিসগুলোই আমরা নিজেরা নিজেরা করতে থাকবো,
হ্যাঁ, ওগুলোতে
প্র্যাকটিসটা।
ওগুলোতে আপনারা ফ্লুয়েন্ট হন, তখন আপনারা বুঝতে পারবেন যে আপনাদের আর কি কি করতে হবে। এই আমরা যখন আপনাদেরকে বলবো যে ধরেন এই এই জিনিসটা আপনি শিখছেন, এটা প্র্যাকটিক্যাল ইউজ হয়তো এই জিনিসটা, তখন ওটা আপনি বুঝতে পারবেন। কিন্তু ধরেন ওটা যদি আপনার প্র্যাকটিসটা না থাকে, তখন আমরা যখন বলবো যে এই জিনিসটা এই এই ওর নাম কি, হাসনাইন
জি
যখন
জি।
আপনাকে ওই আপনি যেটা শিখছেন সেটাকে যখন বিগ ডেটা ইউজ করবে, তখন আপনার কাছে ওটা কমপ্লিটলি নিউ মনে হবে।
আচ্ছা আচ্ছা।
এই,
তাহলে ওই জাস্ট, জি বলেন।
না এখানে আমি জানি না ঠিক এক্স্যাক্টলি সে কতটুকু শিখাইছে। তো এখানে যে বিষয়গুলো আপনার জানার কথা, সেটা হলো পাইথনে ফাংশন কিভাবে ডিক্লেয়ার করতে হয়, কিভাবে সেটাকে ইউজ করতে হয়, লিস্ট, টুপলস, সেট থিওরি কিংবা ডিকশনারি কিভাবে তৈরি করতে হয়, এগুলোর স্লাইসিং ডাইসিং কিভাবে এলিমেন্ট গুলোকে করতে হয়, এই
ইনপুট
জিনিসগুলোর প্র্যাকটিক্যাল
আউটপুট
কিন্তু
এই
ইউজ
জিনিসগুলো
আছে।
মোটামুটি।
এই জিনিসগুলো কিন্তু প্র্যাকটিক্যাল ইউজ আছে। ধরেন আপনার
আপনি, জি
বলেন।
না ভাই, আপনি এখন পর্যন্ত যা যা বলছেন এতটুকু রাহাত ভাই শিখাইছে, মানে এগুলো তো শিখাইছে, আরো কিছু শিখাইছে।
হ্যাঁ, কিন্তু এই এখন যে জিনিসটা ঘটবে, এই যে আপনি প্রতিদিন নতুন কিছু শিখতেছেন। হ্যাঁ, ধরেন আমি আপনাদের সিকুয়েল স্টার্ট করছি, ও এটাকে কন্টিনিউ করবে, প্লাস এই যে আজকে আবার বিগ ডেটা এনভায়রনমেন্টে যাচ্ছেন, আপনাদের যে জিনিসটা ঘটবে ওই জিনিসগুলো আপনারা কমপ্লিটলি ভুলে যাবেন। মানে ধরেন আপনি যদি আগামী 2 মাস প্র্যাকটিস না করেন, আপনার কাছে মনে হবে যে পাইথন আপনাকে আবার নতুন করে শিখতে হবে।
বুঝতে পারছি।
হ্যাঁ, এই জিনিসটা কিন্তু আমাদের নিজেদের ক্ষেত্রে ঘটছে, অন্য যারা স্টুডেন্ট তাদের সাথেও আমরা তাদের এক্সপিরিয়েন্স শেয়ার করছি, তারাও সেম ফিলটাই করছে, যে তারা আসলে সবকিছু ভুলে গেছে, যে পাইথনের সেট কি, এই আপনার টুপলস কি, কিংবা আপনার ডিকশনারি কি। হ্যাঁ, ধরেন একটা ডিকশনারি কিন্তু নেস্টেড করা যায়, একটা ডিকশনারির ভিতরে আরেকটা ডিকশনারি রাখা সম্ভব, একটা লিস্টের
জি
ভিতরে কিন্তু ডিকশনারি ক্রিয়েট করা সম্ভব, কিংবা ডিকশনারির ভিতরে লিস্ট ক্রিয়েট করা সম্ভব। এবং এই জিনিসগুলো ধরেন আপনাকে মানে এই বিষয়গুলোকে এইভাবে ব্যাখ্যা করা যেতে পারে, ধরেন আপনার একটা ডেটা আছে, কাস্টমার ডেটা, আপনি একটা কোম্পানিতে কাজ করেন, সেখানে কাস্টমার ডেটা আছে। ধরেন আমি যেমন সিটি গ্রুপে কাজ করি, তার কাস্টমার ডেটা আছে। এই কাস্টমার ডেটার সঙ্গে যদি আপনি এটাকে ডিকশনারি চিন্তা করেন, তাহলে আপনার কাস্টমার আইডিটা হচ্ছে আপনার কি, আর ভ্যালুগুলো কি? ভ্যালুগুলো হতে পারে আপনার কাস্টমারের অ্যাড্রেসটা কি, মানে কোথায় সে থাকে, তার সিটি কি, তার জিপ কোড কি। হ্যাঁ, তার অ্যাড্রেসের যে 4-5টা ভ্যালু আছে, অ্যাড্রেসের একটা হলো স্ট্রিট অ্যাড্রেস, তারপরে থাকে তার জিপ কোড, তারপরে তার থাকে তার সিটি, তার স্টেট। এই সবগুলো কিন্তু তখন ভ্যালু হতে পারে। এই জিনিসগুলো আপনাকে তখন ওইখানে কাজে লাগবে, এবং আপনাকে যে জিনিসটা জানতে হবে যে হাউ টু স্লাইস এন্ড ডাইস, মিনিং একটা সার্টেন এলিমেন্টকে যদি আপনি ওই জায়গা থেকে বের করতে চান, আপনি কি লিখবেন। এবং ওই জিনিসগুলো আপনি যখন এই কোর্সগুলো মানে কন্টিনিউয়াসলি মুভ করতে থাকবে, আর এটা যদি প্র্যাকটিস না থাকে আপনি সম্পূর্ণ ভুলে যাবেন, এটা গ্যারান্টিড। এখন পর্যন্ত আমরা কোনো এক্সেপশন দেখি নাই। ওই জন্য ওই বারবারই আমি আপনারা খেয়াল করছেন, আমি হোয়াটসঅ্যাপে আপনাদের মেসেজ দিচ্ছি যে প্র্যাকটিসটা কেমন হচ্ছে। কারণ প্র্যাকটিসটা যখন আপনি খুব সহজ জিনিস দিয়ে করবেন, তখন ওটা আপনার ব্রেন ওটাকে সহজভাবে নেবে। কারণ ব্রেন কিন্তু নতুন জিনিসকে ভয় পায়, সেই মনে করে এটা থ্রেট। হিউম্যান ব্রেন কিন্তু নতুন জিনিসকে সিরিয়াসলি ভয় পায়, এবং সে সেটাকে ট্রিট করে থ্রেট হিসাবে। সে ওই জায়গাটাতে আপনাকে যদি আপনি ফোকাস করতে চান, তাহলে তাকে স্লোলি আপনাকে অ্যাডাপ্ট করতে হবে। যদি ধরেন এখন যদি বলা হয় যে পাইথনে একটা ফাংশন কিভাবে লিখবেন, হোয়াট ইজ দ্য সিনট্যাক্স ফর দ্যাট, আমি জানি না আপনাদের কার কার মনে আছে। যদি মনে থাকে খুবই ভালো, না থাকলে কালকে আবার পড়াশোনা শুরু করেন যে একটা ফাংশনকে কিভাবে কল করতে হয়, একটা ফাংশনে রিটার্ন বলতে কি বোঝায়। হ্যাঁ, ফাংশনের ধরেন স্কোপ কি, আপনি ধরেন সেটা লোকাল স্কোপ নাকি গ্লোবাল স্কোপ। হ্যাঁ, এই জিনিসগুলো কন্টিনিউয়াসলি প্র্যাকটিস করতে থাকে। এই যে আমরা সিকুয়েলে যে আলোচনাটা শুরু করছি, যে আপনি এখানে ডেটাবেস বলতে কি বোঝায়, টেবিল বলতে কি বোঝায়, রেকর্ড বলতে কি বোঝায়, আপনি কিভাবে একটা ডেটাকে ডিক্লেয়ার করবেন, এটার ডেটা টাইপ কি জিনিস, ইন্টিজার ডেটা টাইপ কি জিনিস, আপনার এই ক্যারেক্টার ডেটা টাইপ কি জিনিস। ডেটা টাইপ কিন্তু ডেটা ইঞ্জিনিয়ারিং এ একটা হিউজ ফ্যাক্টর। আপনার ইন্টারভিউ কোশ্চেন আসবে এইসব জায়গা থেকে এরকম যে হাউ মেনি ডেটা টাইপস ইউ ওয়ার্ক অন। ধরেন আপনার একটা ডেটা আছে ইন্টিজারে, আপনি কিভাবে এটাকে টেক্সট ফরম্যাটে নেবেন, মানে ডেটা টাইপ চেঞ্জ করা, এই ডেটাকে আবার কম্প্রেশন করা যায়। এরকম হাজার রকমের প্রশ্ন আসবে, এবং এই প্রশ্নগুলো আপনার ব্রেন কিন্তু নিতে চাইবে না।
জি,
কেন? ইটস নিউ। আর আমাদের নিউরো সায়েন্স বলতেছে যে ব্রেন নতুন জিনিসকে ভয় পায়, সে এটাকে রীতিমতো থ্রেট মনে করে। আমার
এই যে জিনিসটাকে আমাদেরকে মানে করতে থাকতে হবে, তখন
আপনি যখন হ্যাঁ এই জিনিসটা যখন আপনি বারবার করবেন, তখন ব্রেন ওটাতে কনফিডেন্স বিল্ড করে। সে নিউরো সায়েন্সের ভাষায় হ্যাঁ সেখানে নিউরাল নেটওয়ার্ক তৈরি হয়, এবং ওই নিউরাল নেটওয়ার্কে যত থিকার হবে আপনি তত কনফিডেন্স ফিল করবেন। আর ওটা যেটা যত উইকার হবে আপনি তত ফ্রাস্ট্রেশন ফিল করবেন। আপনার জীবনে হয়তো আপনি এরকম অনেক স্কিল শিখছেন আপনার এই বয়সে, কিন্তু ওই স্কিল গুলো পরে কোথাও কোনো কাজে ব্যবহার হয় নাই। আপনার কাছে এখন মনে হয় যে ও মাই গুডনেস, আমাকে ওই জিনিসটা আমি এখন আর করতে পারবো না। এরকম কিন্তু অনেক স্কিল আছে। যেমন আমাদের অনেকেই ধরেন ছোটবেলায় যারা ধর্মীয় শিক্ষায় যায়, ধরেন আরবি পড়া শেখে বা অন্য ধর্মের ক্ষেত্রে হ্যাঁ তারা সংস্কৃত শেখে বা আরো যে ভাষায় যেটা আছে, ওটা এক সময় ধরেন আমাদের স্কুল লেভেলে আমরা পড়তাম। কিন্তু এখন যদি আপনাকে পড়তে বলা হয়, আপনার যদি প্র্যাকটিস না থাকে আপনি তো পড়তে পারবেন না, সময় লাগে। তখন পারতেন না, এখন যদি দীর্ঘ সময় না পড়েন আপনি হয়তো এমন হতে পারে আপনি পড়তেই পারতেছেন না। কারণটা হলো যখন আপনি বলতেছেন যে এটা আলিফের উপর জবর নাকি এটা তাসদীদ নাকি এটা কি, কারণ দীর্ঘ সময় না দেখার জন্য আপনার ভিতরে একটা কনফিউশন ক্রিয়েট করতেছে, এবং ব্রেন তখন ওটাকে নিচ্ছে হলো আনকমফোর্টেবল হইতে। ব্রেন যখন ওটাকে সে মানে বিরক্ত ভাব তার ভিতরে আসতেছে, সে তখন মোটিভেশনটা লুজ করতেছে। কারণ মোটিভেশন কিন্তু ইজ এ লিমিটেড সোর্স, ইটস নট আনলিমিটেড। আপনার শরীর যেদিন ভালো আছে সেদিন হয়তো আপনি 20টা পুশ আপ দিতে কিন্তু আপনার গায়ে লাগবে না। কিন্তু যেদিন আপনার শরীর ভালো নাই সেদিন কিন্তু 20টা পুশ আপ দেওয়া কিন্তু কঠিন কাজ, কারণ আপনার মোটিভেশন তখন জিরো। বা অন্যভাবে এটা ব্যাখ্যা করতে পারেন যে ধরেন আপনি প্রতিদিন রান করেন, আজকে হয়তো ওয়েদার খারাপ, আপনার ইচ্ছাই করতেছে না আজকে বাইরে হাঁটার জন্য, অথবা আপনি জিমে যাচ্ছেন না।
Hello.
কে এসে গেছে? হ্যাঁ, ওকে ব্রাদার, আসসালামু আলাইকুম।
Yeah. Hi. Good morning, everyone. Really
Good
sorry
morning.
I'm late today.
No problem.
Okay. So in last session, we discussed some theoretical concepts about what big data is and whatnot. An interesting question was asked that what we will learn in this course. Okay. So the thing is, after this course, we'll be applying for data engineering roles. Now, what is that a data engineer does? Is that we do three things: create, maintain, and validate. Okay.
Brother, we couldn't see
Brother,
your screen.
Yeah, we don't see
Yeah.
your screen.
Just a second. I'm
Okay,
sharing.
sorry, sorry. That was
No,
not
I will just.
you forget, and also please turn on the recording, please.
Recording. Adam, can you do it for me, please?
Recording
see.
in progress.
Okay, it is done.
So, data line. Okay. So, as a data engineer, the font is visible, right? Anyone have any problem with the font?
That's good.
It's fine for me.
Okay. Okay. So, what is a data pipeline? What do you mean by pipeline? For example, in your building, you have a water resource. Okay. And from that water resource, you have pipelines, right? And let's just say it's a kitchen and here is your glass. So it has three components. Your building's water pipeline. It has a source system, that is your water reservoir. Okay. Then we have a pipeline, and then we have your glass, and that is the sink system. Pretty simple, right? You have a tap here, and that brings the water into your glass. But we are not using all the water in the reservoir, and one reservoir has a lot of pipelines in the building going on from one point to another point. Okay. There are a lot of pipelines going on. Now, how do we implement this thing into our data engineering world? Simple. For example, there is a device. This device is generating a lot of data. For, let's say, it's a mobile device. So you have a lot of applications like Instagram, LinkedIn, WhatsApp, and it is generating a lot of data. Now, this data is stored in a reservoir. For our case, let's call it what? An RDBMS system. Yesterday in the last session we understood about RDBMS system, right? RDBMS system, it can be MySQL, it can be Postgres, it can be Oracle, any. Okay. So this device, the data is flowing to RDBMS system. Now from RDBMS, we take this data and we bring it in a distributed environment, HDFS. Why distributed environment? Because the data might be 50 GB, 1 terabyte, 10 terabyte, and processing that in RDBMS is not feasible. Why? I will tell you. Today we will discuss about the architecture of Hadoop, and there you will know why, as a data engineer, we use HDFS as a file system and we don't use RDBMS. From HDFS, we process the data. Okay. With various tools, maybe Spark, okay, it may be Kafka, it may be any tool, okay. Well, we generally don't use Kafka in like stored data. We use it for real time. So let's stick with Spark here, okay. And then from after processing this data, what we do is we have a sink. Now this sink can be anything, okay. It can be again HDFS, or it can be RDBMS, or it can be a totally new Snowflake. What is a Snowflake? It is a data warehouse. In the last class, we saw that what a data warehouse is. Okay, I explained you guys. If you want to recall it, you can visit the last class recordings. Okay, now the processing can also be taken place with Hive. Sorry about this. Yeah, Hive. Okay, so this is our whole data pipeline. Pretty simple, right? What is that? You have a device, you bring the data in your RDBMS. Okay, from RDBMS you put it in HDFS. Then with help of Spark or Hive, you process it and you bring it again into a storage system. This whole is called a data pipeline. So first thing that we do is what? Creation. Okay, the creation of data pipeline is done. As a data engineer, we have done the first step. Now the maintenance. What do we mean by maintenance? The maintenance means that the data that is residing here, the data that is coming from here and residing here, let's say it's 50 GB data. Everyone knows what GBs and TBs are. We discussed in the last class. So the same data is brought here also. And we do this with the help of Scoop. Okay. So the same 50 GB of data is distributed in HDFS. And that same 50 GB of data is processed with help of Spark. And whatever the result is, let's say that after filtering and doing everything that we know, we got 1 GB of data, or let's say 10 GB of data. So this 10 GB of data after processing is residing in this. At each space, we have to maintain that the data, the processing or operations that we perform on the data are performing properly. It is giving results, and the results are being stored in HDFS or whatever the sync system is. So we call this as source and this as sync. And now comes the validation part. So validation means that the same thing. 50 GB here, it should be 50 GB here. Not less, not more. Okay, just because we distributed it amongst different small machines, that doesn't mean that the data should be less or more. Okay, so this is the validation part. These three things, as a data engineer, we perform. Understood? Any question in this?
Yeah, so we have to maintain CMV, create, maintain, and validate.
Create, maintain, and validate.
CMV.
Okay, so we will be learning in SQL, we will be learning MySQL. Okay, we will be learning scoop of how to get data from MySQL to distributed environment. We will learn Spark and Hive, how to process the data, and then we will learn how we store the data, how we read the data, and how we store the data. This whole pipeline will be learned as our data course. Okay, and as I said, there are V's of big data. So we have different challenges, and we will face different problems. We have to drive different results. We'll have to apply different queries and different operations on these. So we will learn each and every one of them. How this system performs operations on Hdfs distributed environment. We'll learn that. Okay, how the whole data pipeline is created and everything. Now, another thing that a data engineer is expected to do is to create pipelines in most efficient way. What do you mean by most efficient way? Two things. One is less cost. Second is quicker results. So can anyone tell me that how can I make this pipeline? Okay, we have this 1, 2, 3, 4, 5, 6 things, right? Let's call this one thing. These are processing. So 1, 2, 3, 4, and 5. Okay, how can I make this more efficient? Right now, what are we doing? We are bringing data into RDBMS, we are bringing data into Hdfs, we are processing, we are syncing. Can I make this more efficient? More efficient means can I make it quicker? The results are getting quicker. How can I do that? Can anyone guess? What can we do here?
I'm not sure, to be honest.
It's about structured or unstructured.
See, in RDBMS, when we are talking about RDBMS, the data is always stored in how? Database, then schema, and table. Okay, so it is structured in this.
Structured. I understand.
Right? But the device, do you think the device will produce a structured data? Your
No.
mobile data?
No.
It will not produce a structured data. So how can I make it more efficient? We have got one step closer to know this. How can we make this more efficient? Any guesses? Okay.
Using
So what we can do? Yes. Who was this?
I say using a Spark.
Yes, we are processing the data with Spark, and yes, obviously, we have chosen a processing unit that is way faster than the traditional map reduce.
The cloud, using cloud.
Okay, cloud. Cloud is again we use cloud for storage only. So okay, instead of storing it here, we store it on the cloud. So we bring cloud in between.
Establish a efficient process, but I don't know the
Yes,
which one is
efficient.
efficient.
Yes. We can make an efficient process in this, and then that is totally acceptable answer. Okay, cloud, and the cloud, the Spark is processing data in cloud, and cloud here we are syncing. Okay, same thing. Who was the one who said cloud? Can I get the name, please?
Hussain.
Yeah. Okay. So what we can do is that instead of bringing this data into RDBMS and then bringing the data in Hdfs, we bring the data directly from device to Hdfs. Same thing, right? Someone will write a Python code, for example. Okay, and bring the data from device to Hdfs. We can write a Python code to bring the data from device to Hdfs instead of bringing the data here. So what we did is we removed these two components from the pipeline. So maintenance of a whole database plus maintenance of scoop, writing queries, everything was removed, and the data and the pipeline just got shorter, right? 2 steps. Bring the data to MySQL. What was the earlier pipeline? Device, DBMS, HDFS, Spark, and sync. Now what we did, we just removed this and we made our pipeline shorter. It became less cost because we are not maintaining two things. Quicker results, obviously, because the data when getting from device, it used to go to MySQL, then then HDFS, then Spark. Now it has directly in HDFS, and Spark and Hive is processing it, and we are syncing the data. Okay, so our job is achieved as a data engineer. Everyone is clear what is the role of data engineer, what we do as a data engineer? Yes. No?
I don't.
Yes.
Yeah.
Got that. Okay. So I'm gonna keep it this way. Okay. Now, another problem with storing data in MySQL. As I said that in MySQL we use what? Database, schema, table. Is that in last class we discussed the types of data, right? Someone right now said about the structured, unstructured. So there are how many types?
Three
Structured,
types.
semi-structured, unstructured.
Yes. So structured, that is RDBMS. Okay. And semi-structured, that is JSON. In JSON we have what? Key value pair. Okay, don't worry about this right now, because when we will actually process the data with Spark, we will learn what key value pair is, how to perform operations, how to use JSON. There are different formats: CSV, JSON, Parquet, Avro. We'll see all of them. Okay, so it is kind of this. name sign is semi-structured data. Okay. And then the third one is unstructured data. Unstructured data can be CSV, TSV, or text file. For example, if I write here and I save this on my desktop as abc.txt, so this just became a text file. Okay, do I see any structure here? For example, if I write 101 and 4000, 102, 1000. I don't have any structure. Why?
No.
Why am I
Because-
saying that I don't have any?
Because I don't know what does 101 means. What is
Yes.
4000?
Neither we have given a name to this field, nor we have given any data type to this field. So it is unstructured.
Yeah.
So let's just copy paste it. Okay. Now the thing is, in RDBMS we can only store structured data. Okay, so if I have to store a data from a device, then what I'll have to do, I'll have to write a program in which I will write an insert query. Insert into values 101 and 1000. Okay, this insert query can only write data because we are mentioning a table name, then we are mentioning the when we create a table, everyone has seen the create table statement, right? ID is int, name is string, varchar, and sal is, let's say, float. So according to this structure, I have to store the data in there. So there's an overhead of writing a code into a query that will write the data in RDBMS. Everyone is able to see, right? This, if I zoom out.
Yeah.
Yeah, good. Okay. So what happens in Hdfs is that in Hdfs we can store structured, semi-structured, and unstructured, all three of them as it is. In I actually showed you a word count, right? A word count file which had 3 lines and having the names with spaces separated. Let me open that. So the thing is that in HDFS, until it opens, let's just finish this. In HDFS, we store the data in any of the formats, in any of the types. Structured can also be stored with the help of Hive. We can store tables in this. Okay. In semi-structured data, directly a file of having this data in a file. If we have this data here, let's say we have a file like this, and it's 102, 103, 104, 105, goes on. this file can directly be stored on Hdfs without any conversion or anything. And then we can process the data with Spark, and then we can write the data. So the benefit of using Hdfs is, first of all, we get a distributed environment, so we are not storing whole data on one machine. We are cutting the data in chunks, and then we are storing it in different hard disks or different machines. Okay, in the RDBMS, what happens is that we don't have a distributed environment here. So that's why first of all, we got the data in RDBMS, and then we got the data in Hdfs, just because we wanted the data to be distributed so that processing takes faster. Now, how is that we process data faster in Hdfs? It's simple. For example, if we have this data, okay, in my SQL. So in my SQL, because it is a single machine, it has what? One CPU. But in Hdfs, what happens? That Hdfs stores data separately in different machines, right? Let's say we have a file of 1 gigabyte. One GB file is residing here. So what will happen in Hdfs case is that it will be broken into 128 MB. When we will discuss the whole Hadoop architecture, we will see why 128 MB. 128 MB here, 128 MB here, here, and here. Okay, and here. So if we divide 1024 by 128, we get 8 parts. So 8 parts are stored on 4 machines. Now this machine has 1 CPU, this has 1 CPU. So we have, in Hadoop environment, what we do is we don't store the data in one single machine as in RDBMS, but we store the data in, let's say, this 4 machines. Okay, it can be 1000 machines, depends on the company. Okay, in the history of Hadoop also we saw that Yahoo actually took the project from duck cutting, and in 2012 or 13, Yahoo made a cluster of 1000 nodes. Okay, with high-end CPUs and like 128 GB RAM, okay, terabytes of hard disks, and it did a processing just to show the capability of how Hadoop can be a better storage system than the traditional databases or the traditional data warehouses. Okay, so what is the benefit of having this data into these small parts? Let's say, for example, that we have this, and we have 6,000, we have 8,000, 9,000, we have 10,000, and we have 3,000. I have written a query. Select cell from comp. What am I doing? Comp is this table. Let's say it says structured data in table comp. Okay, so when I write max salary, max is a method that takes out the maximum of salary. So I have different fields, like this is ID field, name field, okay, and salary field. So I'm finding the maximum of salary. I want that particular row which has the maximum of salary. So in RDBMS, what will happen is that this will compare with this. 6000 came, 6000 compared with 8000, 8000 is higher, 9000 is higher, 10,000 is higher, and 10,000 compared with 3,000, 10,000 higher. So the final result came what? 10,000 here. Okay, but let's say that to make one comparison, it takes 1 minute. Okay, so 1 minute for this, then 1 minute for this, 1 minute for this, 1 minute for this, 1 minute for this. 1, 2, 1, 2, 3, 4, and 5. Total it took 5 minutes in RDBMS. Now we have divided this in Hdfs. We have divided this. So what is happening? Let's just say that this and this. We have divided this into 3 parts. Let's assume that instead of 4 parts, it is divided into 3 parts. Okay, or let's have 2 more records here. So earlier it took what? 1, 2, 3, 4, 5, 6, 7. 7 minutes, let's call it. After 7 minutes, it gave a result of 10,000. Now what will happen in this is that this will be stored on this. Okay, this is stored on this. This is stored here. This is stored here. This is stored here, and this is stored here. When we fire this query, let's say we fire this query with Spark or Hive, what will happen is that this query, let's call it Q, this query will go on here. The same query will be given to this also, the same query will be given to this also, and the same query will be given to this also. So what happens that it takes, let's call it that here also it takes 1 minute only. So in 1 minute, it got the result of 6,000. In 1 minute, it got the result of 9,000. This got 6,000, sorry. And this got 9,000. And this got 10,000. And then this got 7,000. But the benefit is, at this same moment of time, let's say we started the processing at 10:20. So at 10:20, if RDBMS starts, it will finish at what? 10:27. But here, what happens is that 10:20, this also gave a result at 10:20 only. This also, this also, this also, because these are different machines, so they can process parallelly. So they gave at 10:20 only, they gave the result of these 4. Now in the second phase, these 4 were compared, and we got the result of 10,000. So let's just say that making both the phases, it took 1.5 minutes. And in 1 minute we got these, and in let's say 0.5 we got the comparison of this. So the benefit of having Hdfs is that we made the just as we were talking about, we made it less cost, plus we got the results quicker, because Earlier it was taking 7 minutes, and now it is taking only 1.5 minutes. It's less than half. So that is the benefit of using distributed environment. That's why big data, where GBs and TBs of data, and some of some know a lot of companies now are using petabytes. Okay, so petabytes of data can be processed efficiently because instead of one, we are using a lot of CPUs, and we are processing parallelly. So as a data engineer, we fulfilled our two requirements. As we removed two components, it got the cost got less, and as we are using a distributed environment, the results came out quicker. Now the
But
benefit is yes,
okay,
yes,
may I
yes.
ask a
Tell me.
question? Yeah, yeah.
Yeah,
But
sure, sure.
if the if the one machine collapses the information, the data, then how can
Yes, yes.
the RDBMS will analyze all the informations?
RDBMS will, if this single machine collapses, what will happen is that it will discard all the results, and when the machine comes back, it will again start the processing and will give the result. Okay.
Okay,
Now,
okay, but
this is may I know your name, please?
Sohail,
So this is a very good question. Actually, this brings us to another concept of our distributed environment. Yes, you were asking another thing. Please tell me.
okay. The machine one contains the two rows, the machine two, the next
Hmm.
two, machine three, the next three, and the last one, the final two. But
Yes.
my question is, if the machine one collapses the first two rows,
Yes.
then how can the query will come out?
Yeah.
Suppose
That is
the
yes.
10,000 salary columns collapsed, then the result will come the
Yeah.
9,000, but actually the result is
Yes.
10,000.
Yes. So when we divide these things, we call them chunks. Okay. So this has C1. That's, C2, C3, C4. What happens if this machine collapses? The data is lost, as said by Sohail, and it's totally fine. So in distributed environment, what we have is we have another concept, and that is called replication. What do you mean by replication? The general word replication. Replication means making a copy. So when by default Hadoop has a replication factor of 3. What do you mean by replication factor of 3? Is that each data stored in one machine is replicated twice. So we have 3 copies of each data. Now, and this is not like this is the first machine, this is the second machine, third machine, fourth machine. All are there. Okay, so when we are writing the data, it may happen that C2 is here, C4 is here. Okay, there is no sequential write. Any chunk can be written on any of the machines, but we have a replication of 3. So for example, while processing, let's say that this machine got collapsed. Okay, so what will happen is that this is the main copy and this is the replica. These informations are stored in a thing called name node. When we will study our Hdfs architecture today, we'll know what name node is. Okay, so what happens is like this machine just got so, or let's say the 10,000 one, the third C3 chunk here, this got collapsed. So what will happen is that there is a concept of the resource manager also. So let's not get into that right now, but let's say Hadoop will know that this machine is down. So what it will do, it will look for the replication of that. So C3, he found it here. So what he will do, he will process the C3 in this only. This chunk will be processed in this only, and then we'll have the result of 6,000 plus 10,000 here. Okay, so then 1, 2, 3, 4 again compared, and the result is 10,000. In RDBMS, we don't have this replication factor. So if RDBMS machine is down, until it comes up, nothing can happen. But what happens in distributed environment is that we have the copies. So if one node is down, machines we call nodes. In a distributed environment, each and every machine is called a node. So if one node is down, we can use the copy of that particular data residing there, and we can work on that copy. Sohail, clear?
Yes, brother. Thank you.
Okay, everyone clear? Any doubt?
Yes, clear.
I'm sorry. I don't know what happened because my computer shut off for the last 10 minutes. So I'm sorry.
Okay.
I kind of didn't know what you did.
From where did you miss? What was the last thing you?
Last thing I remember, you were on the right side typing, and then my computer turned off.
Yes. Okay. Just a recap, and obviously, Adam, this session is recorded, right? So you will be providing them recordings.
Yeah, they would provide us with all the recordings.
Yeah. Okay.
If it's a lot, I can watch it later. That's not a problem.
No, it is not a lot. And see, what happens is that I was saying that if this data is residing on this RDBMS system, the MySQL system, okay, MySQL system has only one machine, okay, and one machine is storing all this data. And when this data is processed by one machine, what will happen? That it will process 1 row, 2 row, 3 row, like this it will process. And we wrote a query of finding the maximum of salaries. Okay, so what will it do? It will compare each and every row with other row. For example, in our case, we said that processing one comparison takes 1 minute of time. What will happen? That 1, 2, 3, 4, 5, 6, 7. It takes what? 7 minutes, and gives the result of 10,000. Okay. Now, when we bring this data into a distributed environment, what happens that we divide the data into chunks. Let's say that this data was divided into 4 chunks. First, these parts we call them chunks. Okay. First resides here, second resides here, sorry. The third is residing here, the fourth is residing here. Okay. What will happen is that when we fire the query, let's say at 10:20 AM, RDBMS will give the result at 10:27. But here what will happen is that at 10:20 this machine will process the same. So at 10:20 only, and each comparison is taking what? 1 minute. So at 10:21, what we will have? We'll have 6,000, 9,000, 10,000, and 7,000. Okay, and then we have to compare only these 4, and let's say that it took half a minute more. So at 10:21 or 10:22, we got the result. Even if we say like 1 minute of a comparison of all these, then also we got the result in 2 minutes, and here we got the result in 7 minutes. So having a single machine, it takes more time, but as a data engineer, what we do at less cost. So we remove this thing. Okay, so we reduce the cost plus quicker results. Because we are using distributed environment, we got the result in a really quick manner. Okay, clear?
Yeah, I get it. Thank you.
And then a question was asked by Suhail that what happens like if this machine goes down. So what will happen is that in RDBMS, if this machine goes down, it will restart the job when this machine will come up and will give the result. But what happens in distributed environment is that all these chunks are replicated. So we have copies of this one chunk is not residing on one machine but 3 machines, C1, C1 and here also C1. These two are copies and this is the original. Every chunk is replicated in different machines. So if this machine goes out, what it will do, that the Hadoop will know that C3 copy is residing here. So what it will do, that it will compare this and give the result of 10,000 here. So we have the result of 10,000 here. Now what we have 10,006, 9 and 7, the original that we had, and this 4 will be compared. This is not in the case, so 2 results here, 1 here, 1 here, 4 will be compared and still the result will be given in 2 nodes. So even if one node is down, it doesn't matter, the result will be given in the same time. So that's how we make the results quicker, plus we make cost efficient. The another benefit of Hdfs is it stores all types of data in here, because it is storing. Come on, what happened? Oh, caps lock is not there. Oh, sorry. Either it may be a structured data or a semi-structured data or an unstructured data. Hdfs can store all the things because it is a file system. In files, for example, in our Windows file, okay, we have a folder. Let's say we have this folder. In this, what I do, I have these kind of files also. When I say series, I have video files also. In the same drive, in the same folder, in the same drive like F drive, I have all these folders. Different kinds of data are residing at the same place. Okay, but this cannot be done in RDBMS. We can only have structured data, not even semi-structured, not even unstructured. So that is the benefit of using Hdfs. Okay, so are we clear on what as a data engineer we are expected to do, and what are the things we are going to learn in this course? Any doubt in that?
Yes, it's clear.
Yeah.
Yes.
May I know the name of the gentleman who asked that what are we going to learn in this course yesterday, last session?
Yeah, Hussain.
Yeah. I didn't get your name. Sorry.
Hossain. Hussain.
Acha, your name is also Hussain. My name is also Hussain. So I thought you were calling me.
Yeah.
No. Yeah, okay. Yeah, Hussain. Are we clear on this?
Yeah, thank you.
Yeah. Okay. And with whatever I said right now, we have 2 additional things, or I think it's 2 only. One is Airflow and one is Kafka. Okay, so how do we incorporate these 2 in our pipeline? What Airflow does is it does an orchestration. What do you mean by orchestration? Is that we are starting from here, we are bringing the data. From here, we are processing this, we are doing this, we are doing this. So each and everything, like we are doing a task. bringing the data, processing the data, storing the data. Everything is a task. So all these tasks can be maintained by a tool called Airflow. Okay, it's just a fancy name. Just it is that the flow of the data, the processing, the tasks can be maintained by this particular tool. It has a lot of advanced features. It has a GUI. For example, like when we started the Hadoop, so I'm working on my laptop, and this laptop is not that much, like it doesn't have that much RAM in it. My system is creating some problem. That's why it's taking time to start and all. So see, right, this we are working on what we call a terminal. Okay, but this Hadoop has also given us a GUI where we can see the health of the, okay, we have one data node with us. Okay, the data node, this tick means the data node is up and running. We also have another, all applications. Whatever applications we fire, we can monitor that. So it shows the capacity scheduler. It has all these. So this GUI, what it makes our life easier. Okay, all the applications, how many are running right now, how many applications have been finished, failed, killed. So all these things, if we have a GUI, this is called a GUI, graphical user interface. This is what CLI, command line interface. So with GUI, our life becomes easier. So what Airflow does is that it provides us a GUI also. So we can monitor that this task is finished, okay, with this task is killed, and this and that, everything. And then comes Kafka. What Kafka can do is that it can process the data in real time. Okay, generally what we do is that we bring the data from devices through Kafka and store that in Hdfs, so that if we have any real time need, for example, you go to an ATM, okay, you withdraw, and you get a message on your mobile that this much money you withdrawed and your balance is this now. Okay, this is not a batch process, this is a real time process. OLTP we call them, online transaction protocol, OLTP. So the thing is that transaction data is always live data. In Hdfs, what is there? That these are the you can say the attributes or information about an employee, let's call it. It's an employee, and the employee database and the employee data is historical data only, right? It's not live data, because every day your salary is not changing, every moment your salary is not changing. Your salary is a constant thing. You may get an increment in 1 year, and after the data may update. But when we process this kind of data, it is called what? A batch process. Because we have this data is not coming live from anywhere. This is stored here, and we are processing a stored data. For that, we can use Spark. Okay, if we want to use SQL queries, we can use Hive. We can also write SQL queries in Spark, we'll see. But the thing is that Kafka, what it does is that as and when the data arrives, ad hoc we call them, as and when the data arrives, it can process and it can give the result to sync. Okay, if we need a system like that, for example, when we are withdrawing money, at that time, for example, in we have a credit card fraud. Okay, at that moment of time, if the purchase is not legit, you can block the card then and there. That kind of facilities requires real-time processing, and real-time processing is done with Kafka. So now we are clear that everything that we are going to learn, how are we going to implement this, and how are we going to use it in our project also, and in our day-to-day life also. Okay, as part of our career. we will be doing everything that is in this particular box. Okay, so I hope I'm clear on the agenda of this course, and I hope I've given you some of the benefits of Hdfs, why we use distributed and not single environment. Everyone is clear, right? Yes.
Yes.
Yeah, good. So let's take a break of 5 minutes. Just give me 5 minutes, and then we'll see our virtual machines. Okay. I want each and every one's virtual machine to run smoothly, because tomorrow we have SQL session, and we'll be using MySQL here only, maybe MySQL Workbench or on terminal, both of them.
But problem is I can't finish the download. Yeah, it's too
Okay,
big.
that's why I'm taking this in middle of the class, no, so that if any problem is there, we can troubleshoot it here only. Okay.
Okay.
I don't want anyone to face any problems when they are practicing or running queries and anything. So right now, after break, what we'll do is that
আমার একটা শাখাত ভাই লাইনে আছেন?
হ্যাঁ হ্যাঁ
আমারটা শেষ মুহূর্তে এসে ফেইল দেখাইছে।
আমারও সেম আমার আবার
সে আগের পজিশনে আসছে, তারপরে উনি এখানে 20 মিনিট অপেক্ষা করবেন, তারপরে আমাকে রেজাল্ট দিবেন। আগের পজিশনে আসছে আবার 30 সেকেন্ডসেই অলমোস্ট 90% কভার করে ফেললে।
আমি
একটা সার্কেল দেখায় না, সেই সার্কেলে।
আমি ওই জন্য রাব্বানি ভাই কল দিয়েছিলাম, এরকম ঘটনা যে এরকম তো হচ্ছে না।
বুঝছো শফিন? আজকের মধ্যে শেষ হবে কিনা ডাউনলোড?
আমারটা কমপ্লিট হয়েছে ভাইয়া। শাহিদ ভাই।
জি ভাইয়া।
আমারটা হয়েছে, শেষ হয়েছে।
ও যাক, আমারটা লাস্টের মুহূর্তে এসে ফেল দেখাইলো। দেখি না হইলে পরে আপনার কাছ থেকে নিয়ে নিব।
আমারটা জিপের মতো আসছে। জিপ এটা কি নাকি?
হ্যাঁ, জিপ
চকলেট।
মানে অনেক বড় ফাইল তো জিপ হবে ওটা।
জিপ দেখাচ্ছে। হ্যাঁ, জিপ
হ্যাঁ,
করছে।
তাহলে
তাহলে তো এটা হয়ে গেছে। আর একটা আছে, ওটা তো করতেছে ইভেন টু হার্ড অফ স্পার্ক, ওটা তো করা যাবে না। জিপটাই আমাদেরকে করে রাখতে দিবে না?
হ্যাঁ, জিপটাই রাখেন, পরে ওই যে আমাদের ইনস্ট্রাক্টর হোসেনের বাকিটা বলে দিবে কিভাবে করতে হবে।
ওকে
ভাই ফাইলটা জিপ ছিল, এটা আনজিপ হওয়ার পরে ডাউনলোড হয়েছে, বুঝছেন?
আনজিপ হওয়ার পর ডাউনলোড হয়েছে এটা।
ফাইল ট্রান্সফারের সময় জিপ করে ট্রান্সফার করলে ওটার রাস্তাঘাটে ছড়াই ছিটায় পড়বে না, এই জন্য জিপ করা হয়।
বুঝতে পারছি। এটা এখন কি করবো? এটা আপাতত ওনার ক্লাসে কি করে?
এখন করবে, উনি দেখাই দিবে আপনাদের।
আচ্ছা আচ্ছা, ঠিক আছে।
আমি কি সহজ ভাবে বলছি, কিন্তু মাইন্ড করেন না প্লিজ।
না,
না, মাইন্ড করার কিছু নাই, ঠিক আছে।
আমরা তো
মানে ওই
জানি না জিনিসটা জানার তো
বিটুইন ট্রান্সফারে কোনো ডাটা লস্ট হবে না, এর জন্য জিপ
হ্যাঁ
করা
হ্যাঁ,
হয়।
না ঠিক আছে ভাইয়া, থ্যাংক ইউ।
বুঝতে পারছি।
আমাদের কলেজে এক স্যার ছিলেন, তো উনি পরিসংখ্যান পড়াইতো। স্যার উদাহরণ বোঝানোর জন্য কখনোই ভালো কোনো শব্দ ব্যবহার করতো না। চুরি, ডাকাতি, ছিনতাই এগুলা বলতো। তো স্যার বলতেন, স্যার আপনি এগুলা বলেন কেন? দেখো ভালোগুলা বললে ভুলে যাবে, এইভাবে বললে এই উদাহরণ মনে থাকবে। আলটিমেটলি এখনো মনে আছে স্যারের অনেক উদাহরণ। তো স্যারের কথাটা ঠিকই, সবসময় আপনি যেটা বললেন যে ছড়ায় ছিটায় পুরো যাবে, দেখা যায় জিপের ডেফিনেশনটা এইটা দিয়ে মনে থাকবে। ব্যাপারটা হচ্ছে বুঝা, মনে থাকা।
জি জি।
কলম তো ওই ওখানে দেখো, ড্রয়ার এটা।
চার্জারটা তো লাগাই দাও। ওই যে নিচে দিয়ে টেবিলের নিচে আছে।
ও টাইমার আর কি। টিচারের টাইমার, 5 মিনিট ব্রেক।
Everyone's here? Hello?
Yes, sir.
Yes.
Yeah. Okay. So, what I want to do is that I want to, anyone, who was the one who was facing the problem downloading it? I think it's Shah.
Yeah, I'm facing it too. What happened was I was downloading it, and then
Yeah.
for some reason my screen it just went like blind, and then I had to restart it, and then it like the download failed after like 30-40 minutes, more than that actually, like almost an hour, because I started
Oh.
downloading like 20 minutes before class started. So, and then like 10 minutes
That's,
ago it was showing like it failed, so I'm
see,
re-downloading it again.
Okay, that's what I said. Like we shared the files in I think 10:30 in the morning there, New York time. So you
Yeah, I
you had
didn't know it was
above
gonna take
11
that long.
hours to download. That's why I shared it like this much, because I know that sometimes internet is proper and the file is also 20 GB and something, so it's gonna take time.
Yeah,
Okay.
my download is complete.
Okay. I want is Gulam here? Rabani? No, or Adam?
Yeah, Hussein
Yeah,
bhai,
I'm here.
Yeah, Adam.
Both of us here.
Can you share your screen so that I can install it
Yeah.
on your machine? Give me the control so that everyone can
Yes.
see and know.
Sure. Giving you that.
Okay. So how do you stop sharing on this one? I'm used to Google Meet, so I am stop share is here. Okay. Yeah.
So share screen,
Okay.
share. Do you see my screen?
Yeah, I can see your screen. Everyone can see Adam's screen.
So I downloaded the file
Yeah,
here.
somebody are
Yes.
Yes.
So here are the files.
Here is the file. Okay.
And let me, and yeah, and request the control. Yeah, so you have the control now.
Okay, just a second. So here is what we do is, okay, Adam has 7-zip. That's good. Okay. The thing is that the file, the folder, the software folder, it has like 5 folders. Okay. So those people who don't have 7-zip can download that 7-zip from like 7 download. I have provided it in the software folder. So if you want to download from there also, it's fine. You just go in the software folder and then you will see the 7-zip and you can download it again. Okay, so here download 7-zip and take the 64-bit download exe link. Okay, don't go for this beta version, go for this 19 version for Windows. So you download this and then you install it. Installation is simple, next, and you have your 7-zip with you. Okay, so here let's use 7-zip to extract this. Let's call it extract here. Oh, this is going to take some time because okay, like a minute or so. So meanwhile, those who don't have 7-zip in their system, meanwhile this is extracting, please download the 7-zip and install that and unzip this Ubuntu machine. If you want to watch the video and do it afterwards, it's completely your choice. Okay, if you want to do simultaneously, you can do it with me. Actually kind of forgot because I was thinking that when I'll start the class, I'll take this screen of someone and I'll unzip this so that we can save some time. I forgot that and I started all this. I should really make the notes of what we are going to do step by step. So yeah, I wanted to talk about one thing also, about assignments also. Okay? So we have time, so let's talk about that. So after today's class, okay, after we have discussed the architecture of Hadoop 1 and Hadoop 2, I'll be giving some assignments to you. Okay, these assignments are nothing but interview questions that have been asked over the years from different companies. So you're gonna have to go to internet and you're gonna have to find the answers. Okay, and if anyone is unable to do that, I'll need the reason why. Okay, don't expect me to spoon feed you. I'm not going to do that. I'm not going to provide the answer until and unless I get response from you. Okay, first of all, you will have to try and find the answer because
sorry,
yeah,
Hussain, one thing. It says there is not enough space on the disk. So I think we should do it in D drive instead of C drive. Okay, because I have the space in D drive.
Yes, sure.
Yeah.
D drive your space, right? So, yeah.
And D drive, I also created folder for you, name Hussain.
Okay.
Go
this,
down.
right?
Yeah, that is that. Yeah. Double click on it. Yeah.
and downloads.
কিটা?
ম্যারাথন
এরকম না। যাও তুমি ঘুমাও।
তাহলে কালকে
সকালে ইনশাল্লাহ ওদের স্কুলে দিয়ে
Okay, this will what do? This will not create another root folder of this name in this and then store that. So you can check this option when you are extracting. We don't want like folder and folder and folder like that. Okay, so regarding the assignments, you're gonna have to go and find the answers. Okay, if you are unable to find the answer, that's not a problem, but I need you to try. You have to try first, and then whatever it's remaining, okay, we can. Sorry about this. Whatever is remaining, we can do that. Okay, so because these two sessions have been theoretical, so the questions that I'll be giving you will also be theoretical, but these are the questions that are asked. For example, there's a question that what is the difference between Hadoop 1 and Hadoop 2 architecture. Okay, so you need to know the architecture of Hadoop 1 also and Hadoop 2 also, so that you can say why Hadoop 2 came in picture. What was the drawbacks of Hadoop 1? Second is the block size. What is the block size in Hadoop 1 and what is the block size in Hadoop 2 and Hadoop 3? Okay, Hadoop 2 and Hadoop 3 are similar. Hadoop 3 is actually on performance side, it's giving better results, and that's why it came in picture. Fundamentally, Hadoop 2 and Hadoop 3 are same. Okay, and in next class we'll be learning SQL. So right now, because we have time, can anyone tell me that exactly the topics or points that you have studied in SQL till now? Anyone? Hussain, Sohail, anyone else?
Actually, we learn very initial stage, like only create a database.
Whenever,
create a
just a
table.
second. Guys, this is like the second session, so I don't recognize each and everyone's voice. So I would please request you that whenever you interact with me, just call out your name first and then interact with me, so that in a few sessions I'll get to know that who is giving me answers, who is interacting with me. That's kind of important for me also. So yeah, you are?
Yeah, I'm Hussain.
Yeah, Hussain, yes.
Yeah, our class is like just beginning, the initial
Okay.
stage. We
Okay.
learn like create database, create
Okay.
file, and create table, inner join.
Okay, joins. Okay.
Yeah. And
Okay. So
yeah, that's it.
got that. So
No,
I'm gonna have to.
Sorry, this is Adam. So it is in true sense. We actually didn't start to join yet.
Okay.
So as he mentioned, it is very preliminary. Yeah, it is very preliminary. So we
Mhm.
started how to create a database and how to use it, how to show the databases, how to show the tables, what is the meaning of describe table, and how to create a table with the data type, and how to insert data into table, and also the first select statement to select all from the table. So that's all. So
Okay.
we didn't
Select.
yeah, we
okay.
didn't dig
So,
deeper. Yeah. So
See,
you can start.
in the last session we saw a few questions, interview questions. So there was one question about asset transactions also. So asset transaction is a theoretical concept. I'm not saying that I'll take it tomorrow, but we are gonna have to study some of the theory and the functionality of SQL also, because these are also the questions that are asked in interview. My job as a trainer is to make you ready for interview and beyond. Okay, so that you don't face a problem when you are in the job, and to get into the job, you're gonna have to crack the interview. For interview perspective, all these things that I'm teaching you, each and everything is regarding interview perspective only. Okay. Okay, so don't take that we are having a lot of theory in this, because in round 1, round 2, round 3, however many rounds you have, one round is going to be about all the theoretical questions. Okay, because for example, people will ask you that we have this configuration of our cluster, we have 5 machines, we have this much RAM in each machine, we have this much cores, so how long will it take to process the data? I am facing a problem of running out of memory, how will I solve that problem? This is not related to coding but related to architecture. So theoretical sessions are as important as the programming. Okay, to get into the company and do the programming, you're gonna have to first clear the interview. An interview, you're gonna need to understand the architecture of each and every component. Scoop architecture, Hive architecture. Why do we have Hive? It's not just about writing queries. Okay, Hive makes the data into partitions, buckets, and this, what this does. Okay, this is. So if you have a folder, inside a folder like this, our main folder is this Ubuntu 20 Hadoop Spark. So if it is inside some other folder, just bring it outside. Okay, and you can delete this. This is an empty folder. We don't want that. Okay, so Adam, you have only downloaded this one, or you have downloaded the other software also that were in there?
Yeah. No. You saw the name already. Go back to Hasnain.
Acha, the software is one. Okay, the software is one. Okay.
Yeah, the top one. Yeah.
Okay, yeah. So what are we going to do here is that we are going to install, and this is the extraction. Oh, I'm sorry, I made a mistake. I didn't provide you with the virtual box setup. Adam, I need to share my screen.
Okay. Let me stop share.
Yeah. Okay. So what I'm going to do in this software, this is how can I, yeah, virtual box 6.1. Okay. Just a second, okay, you guys. I'll give you this virtual box software also. It will hardly take a minute. Those starting sessions are going slow, but once we have everything ready and everything like get going, and we get into the coding part, okay, things will run fast and you'll have like practical assignments. Okay, so don't worry about like, yeah, we are getting really slow, or this is too much theory when we'll get to practical. Don't worry about that. Okay. Everyone, just look into your chat. I'm giving you this. So just go to this.
Where did you share?
In the chat.
In
Oh,
WhatsApp.
in the
Yeah.
WhatsApp. Okay. In the
What?
WhatsApp chat box.
What?
Okay. Yeah.
Okay, Adam,
So
I want your screen. Okay,
yeah, I'm
Can you
downloading. So
share your
I'm
screen?
sharing
Okay.
the screen now. Yeah.
Yeah.
Where did it go? Okay. So share screen, share, boom. Okay. So it is downloading here. I think it is done. There you go. Approve. Yeah. So
Okay.
here.
So what are we going to do is just double click on
It's
this.
the virtual box, right? Like
Yeah, this is
6.1.
VirtualBox 6.1.2. Okay. So I'm giving this specific version because I'll be giving you the extension. We're going to use the extra quick launch.
So am I
Extension
just
pack
like
also.
supposed to just click next, and that's it? I'm not supposed to choose anything, right?
No, I just removed those two options. If you want, you can keep them also. It's not. If you want a desktop shortcut, you can keep the desktop shortcut also.
So it says virtual application, virtual USB support. Like, do I choose any of those, or do I just like press next?
It is not showing in mine. What is showing in yours? Virtual USB didn't come
So
here.
when you go next here, oh no.
Okay. You can keep the default options. Okay, it's not gonna make any systematic change in your computer. You don't have to worry about it. Okay. So whenever it shows a new, you can just say no, I don't want to do solar. So what we do is we go to tools and then we add the machine. We go to our location of where we had extracted that, and we have this blue box. Okay. What am I going to do is go here in view, file name extensions. Okay. What will this do is just refresh. So we have this blue one, VBox. This is only showing. We had 3 files here, but this will be showing the VBox one. So we open this. Okay, anyone here has a system that doesn't have 16 GB of RAM, lesser RAM than that? Anyone?
No.
All of them have at least 16 GB of RAM?
Yeah.
Yeah, good. So here I have given the base memory as 12 GB. Okay, and the hard disk I have kept it at 60 GB. That will be more than enough for our course. Okay, so we start it here. The first time it is going to take some time because it's building everything. Depending where you keep your folder, like if you keep your folder in an SSD, the machine will start fast and responds fast. If you keep it in your HDD hard disk, the machine will take. Now, I'm not saying it will be slow, but to start, it will take some time.
So anybody knows what is the meaning of Ubuntu?
Anybody here has a Linux environment? What is Linux? Anyone?
Ubuntu,
Yes,
Ubuntu
I know
means
it.
Yeah.
humility
Humility
Please,
to
to
others.
others.
Good,
yeah.
you got it, man.
Please, tell me what is Ubuntu and what is that?
I don't.
What do you understand by Linux? Please tell me. So, guys,
Linux operating system and operator and Ubuntu is the flavor of Linux
yes,
maybe.
yes. Linux is an operating system, okay, which is designed on top of Unix. Unix was made, and on top of Unix, Linux is developed. And we have different kind of Linux flavors. Like we have Ubuntu, we have CentOS, we have Red Hat Linux. Another is Kali Linux. So these different distributions, what they do is that they have different like the core functionality remains same of Linux, but you may find some syntax change. For example, in CentOS there is a syntax called yum, and in Ubuntu the same syntax is apt-get. Okay, so that is some of the differences in different flavors, but Linux remains same. Okay, all over the Linux command, for example, if to create a directory we use a command mkdir, that is same in all the flavors. There is no change in that. Okay, so you can use any flavor, but the core operating system that we'll be using is Linux. So the username is my name. Okay, and this is the password. Okay, just keep in handy. It's a simple thing. Welcome with a capital W and at 123.
Assalamu alaikum bhaiya.
So now we have this.
আমার কাছে যে ক্লাস হচ্ছে ভাইয়া, মাসুদের সঙ্গে কথা বলেন। না না সমস্যা নাই, কথা বলেন।
হ্যাঁ এই তো ঘুমাইনি লাবিবা। ও লাবিবা কল করা শিখে গেছে।
Okay, you got that right. We go to devices and then we do insert guest addition CD image, and then when it will prompt for the password, you give the password and then it will install this. This is the one. Okay, once you do this, it will remain there. Please don't eject it or do anything. Okay, it is a functionality that is needed for VirtualBox to run on Windows environment, to run it smoothly. Okay, so that you don't face problems when you are dealing with that.
ভালোই আছেন সবাই?
Everyone is doing with me only, or they are waiting for doing it afterwards?
আচ্ছা ঠিক আছে।
I'll do it afterwards.
Okay, no problem.
Yeah, I'll be
Anyone who
honest.
is
I couldn't keep up with you, so I'm probably gonna
no,
have to
it's not hard and fast. It's just that you know, in the next session that we'll be practicing SQL, so we'll be doing on this only. Okay, we are not going to use Windows machine, this workbench. We are going to use the workbench here only, and I prefer using terminal. I prefer using this one, not the workbench, but I prefer using this one. Okay, because in real time you will be writing, you will be submitting your jobs on terminal only. So you know, as soon as you get So when it shows that press return to close this window, just press enter. Okay, and now you have to restart your machine. So go to this, log out, power off. It will prompt you, here is restart. So again, welcome at 123. Please don't change the password. Okay, you can because if you forget the password, then we'll have to recover it, and it's a long process, and I don't want that. And there's a good chance I'm going to ask you to, you know, again extract that and do everything from scratch. You know, the keep this rar file in handy. Okay, if anything happens, and we have to again extract this, so don't delete this rar file. It's gonna take to like 20 GB of your space, not that much, 17 GB I think. Okay, so keep that in handy. If anything goes wrong in your environment, your machine is not working, we might have to reinstall the machine, so that at that time you don't have to download that 20 GB again. Okay, once it starts, then we'll get to the Hadoop 1 architecture today, and tomorrow after the SQL class I'll take Hadoop 2 architecture. Okay, because right now, because of the extraction and I was also late in the class, we have lost some time. Let's go on in here. Why is it taking this much time? Okay, Adam, this will happen.
Yeah.
Okay, so
Yeah.
let me share my screen, and this is the same. The machine will start.
So let me stop
Can
sharing.
you stop sharing so that I can
Yeah.
go on with architecture?
Okay.
Okay, everyone can see my screen?
Yes.
Yes.
Okay, so now we do Hadoop 1.x architecture. 1.x means that 1.x means that it may be 1.2, 1.3, 1.4, or whatever the mini version may be, doesn't matter. But in 1, the architecture remains the same. So what Hadoop 1 architecture says is that we have a cluster. Okay, a cluster is nothing but a group of machines. In typical environment, in typical company environment, what you will have is that you have master and slaves. Hadoop basically works with this master slave architecture. So we have one master, and let's say that We have a standard 1, 2, 3, 4. 4 slaves. Okay, so this is this one. Two. Okay, and this is what? Master node. In master slave architecture, what we do is that this master will send all the code that, for example, we have written this select max query. Okay, we submit this to this master, and this master will send this code to each and every one of the machines. But it's there are things that goes on in this. For example, when in our machine we did start DFS, so we had some resources started. See, name node, data nodes, secondary name nodes, and then when we did start yarn sh, we had resource manager and node manager. Okay, in this we have Hadoop 3. We have Hadoop 3.2.1 installed. So that's why we are having yarn as a resource manager and node managers. In Hadoop 1 architecture, when we start the process, we have name node, secondary name node, data node, job tracker, and task tracker. Okay, these are the 5. You can in Linux term it's called daemons. And what are daemons? These are processes. Okay, 5 processes are started when you start a typical Hadoop environment. So these 3 resides on master, and these 2 resides on slaves. So what we have here is name node, secondary name node, and job tracker. And here data node, task tracker. So data node and task tracker are various. In each of the slave, there will be one data node and one task tracker. Okay, there might be multiple data nodes also, but I have not worked with that, and no one actually creates that. Okay, people generally make this is one machine. Okay, this has its own CPU, own cores, own CPU, own memory, own hard disk. CPU, memory, HDD or SSD, whatever it is. Okay, so now the architecture goes on that when you submit a job, okay, that for example, let's talk about the storage first. Okay, so in storage, what we have, is this whole thing. These will make your HDFS. The HDFS that we were talking about in our pipeline is made by these slave nodes, because the slave nodes has its own memory, has its own hard disk. So when we say that we want to store a data into Hadoop file system, okay, how we do that? We do it with a command called hdfs dfs put. We give our local path, let's say home, Hussein, and file name, and then we give our Hadoop path. For example, Hadoop, I have also made a folder home, and in there also there is a folder Hussein, and say file name. So this put command basically puts your data that is residing on your local machine here. For example, on my desktop, I have data on my desktop, and I want to put that data into this environment. Browse the file system. Okay, so this is what a Hadoop file system. So I want to put my data in this particular location from my local file system. So what I'll use the command as put. Okay, this file can be any CSV, JSON, text file, any file. Okay, it will just copy from my local and put it in Hadoop. So this forms HDFS. Now what HDFS does is that it distributes the data and stores chunks in each and every one of them. Okay, how does it do that? As we learn the components, we learn the architecture. Okay, so first component that we learn is data node. Because we are talking about HDFS storage, so we learn first about data node. What data node does is that it keeps the track of all the memory and hard disk and everything the node has. Okay, and it creates a log for that, and it gives this log to name node. Okay, what name node does is it maintains a register. Okay, in this register, basically what it maintains is that this data node information is given, this data node has given me this information, that information, all these informations are stored in name node register. This register, we call it a meta store. This is just a name, okay, because it is storing what? Metadata. Now what is metadata? Metadata means data about data. It is not storing the actual data. The actual data is stored in this machine, and the actual data what is stored is known by data node. But the data node is saying that I have, for example, we have 1 GB of data, and we have divided that into 128 MB blocks, which is the standard. So we have what? 128 MB chunks. So let's say it is B0. B0 is stored here. B1. B2. B3. B7. B4. B5. Okay, it's not necessary that it will be divided equally. Every block is of 128 MB, and this is by default. Okay, this every block, for example, if you go here, you see block size is 128 MB. Okay, the size of this file is 72 bytes. Now if I store another file here, it will not be in the same block, it will be in a different block, not because it is a different file, but because once I've written this data, okay, this block, let's say it's called B0, is occupied and it is fixed. So you cannot overwrite a block, or you can overwrite a block, but you cannot append to a block. You cannot add data to a block. Once a block is formed, however, how much data is in that block, it doesn't matter. It's only bytes. There's a lot of wastage, right? Because this is megabytes and this is only bytes. But the thing is that another file, if let's say it's 72 kilobytes, then also it will not be stored in this block. It will form a different block, not because it's another file, but because this block is reserved by this when it was written at that time. So 28 chunks, 1 2 3 4 8 chunks is there, and obviously we have replication.
So in the block, the rest of the spaces will be unused.
Yes. If I have a file of 1 GB, then 128 MB 8 blocks will be formed, and the thing is that it will store equally. But if I have a file for say for example say 125 MB, then also the 3 MB is waste. Okay, so that's where we have a concept. Okay, we'll discuss it later when we discuss further in the architecture. We call it small file problem. Small file problem. This is also an interview question asked many times. What do you mean by small file problem? Okay, we'll discuss that once we get ahead in the architecture. So 2 has one replication, and where's the other one? This. Okay, B3 has one. No, B3 has one replication, and this is the another replication. I think we have covered everything. B4 has replication or not? There are 3 applications of each and every one of them. Okay, so this information that I have, this is the original copy, and then 2 replications here is stored by this data node, and this information is passed from data node to name node, and the name node maintains that in a meta store. Okay, metadata means that data about data. The original data is B0, B1, B2, but information about which node S1 has B0 original and copies are in S2 and S4. This metadata is stored by name node in a register. Okay, now we come to submitting a job. For example, we have submitted this query. Okay, what will happen is that then a job tracker will come into picture. Job tracker will talk to name node and get all the information about where the data is residing. For example, we get max sal. Okay, let's say our company data is only in this 2 nodes. Okay, the company data is only in these 2 nodes with replication, everything. Only it is that much data that occupies only 2 nodes. Other 2 nodes is not occupied. So this information is with data node, and data node has given it to name node. Now when we submit this maxal job, this job tracker will talk to this data node. Okay, and this the job tracker will talk to this name node, and this name node will provide the information that these are the 2 nodes S1 and S2 where the data is residing. This is the course that it has, this much amount of memory it has, so you can start your job. So what this job tracker will do is that it will take this code and it will let's call it Q. Okay, so it will take this Q and it will map this Q here and here. Another benefit of big data processing is data locality. This is also asked. Okay, what is data locality and benefits? For example, there is a simple thing on internet right now. If you want to watch, if you want to process, like if you want to post something, for example, you want to find what is on Google, you go and you say calculator 2 plus 2, you got 4. Now what are you doing? From your machine you are sending a data to, and you are sending another data to, and you are sending in what you want to do. Okay, this data is sent over to Google server, Google, and at that server there is a calculator, a process made, a code is written which calculates this and gives you the result back. But the thing is that from your machine you are giving data to Google and you are giving the operation to Google. The operation is residing on the Google. You are just giving that I want to perform plus, but you are not telling Google how to do it, right? The operation, how it will add, is the code is written on Google server. But here what is happening is that we are submitting it to a machine, a distributed machine, a master node, and that master node is sending the code to each and every data node. The data is not moving. In our case, the data was moving from our system to Google, but in this case the data is residing on these nodes only and the code is moving. It has made 2 copies of the code and it is giving this code to these both nodes. So this is what data locality means. And the benefit is what? That right now the data is 128 MB, 128 MB. It may be 128 GB and 128 GB. So if it is 1 terabytes and we divide that into 8 chunks, okay, it will be what? But the thing is that there will be blocks, obviously 128 MB blocks only, but there will be like 128 MB blocks will be 1024 blocks, that will be 128 GB, something like that. Okay, so you can't move that much data into a master node and then process it, okay, and then give the result, because this is also having its own what CPU, memory and hard disk. So if you bring this much amount of data, like 128 terabyte of data into this, it will run out of memory. So this was the problem that was solved with distributed environment Hadoop, that we have data locality now. So what will happen is that we submitted a job. This job was transferred to slave nodes. The processing will take place. At that time, this guy will come in picture, the task tracker. What this task tracker does is that it continuously sends messages to job tracker that 20% of the job is done, 40% of the job is done, 80% of the job is done, like this. As it continuously sends the data to this job tracker, it keeps that, yeah, this node is alive and it is computing, this node is alive and it is performing properly and the execution is going on. Okay, so we have understood that data node, task tracker, job tracker, name node. Okay, everyone is clear like till this? Any questions? Anyone? Hello?
Actually, a lot of things I have to watch
Yes,
this
yes,
video
yeah.
many times.
Again,
Yes.
yeah. No. It's not a problem. See, I'm not saying that you have to grasp everything at once, but try to understand that. Okay, just bear with me. You have any problem? There is a WhatsApp group. Okay, you can post your problem there. I'll try to solve it then and there. Or we have you can ask in the next session or the next session or after 10 sessions also. It's not a problem. Okay, whenever you're comfortable. So after this task tracker has given it 100%, 100%, the job is completed, and then the result is given back to us, and the result was 10,000. So the result is in this master node. We can take the result from this master node. So what about this secondary name node? Why do we have a secondary name node? We actually, Sohail asked me about this, right? So what happens, okay, if any of this node goes down? Name node has all the information of the replicas also. So if this particular node goes down, what will this task tracker and this data node? Task tracker is talking to this job tracker. Okay, this is during the job. Before the job, if this this node is unavailable, then data node will send you can say data node. We in Hadoop terms we call it a heartbeat. Okay, every data node in a few amount of time sends heartbeat to this name node that I'm alive. Okay, as soon as it stops giving the heartbeat for in that particular interval of time, name node consider that this data node is gone. So what it will do, it will look for the replicas, and when job tracker asks it, it will give, okay, these are not the nodes, these are the nodes, S2, S3, perform your operation on S2, S3. This is before submitting the job. Now what happens if during the job anything fails? So the task tracker is also giving 20%, 30%, we saw that, right? 20, 40, 60%. As soon as this stops giving during the execution, task tracker stops giving the the progress of the data, so the progress of the computation to job tracker. This job tracker will ask name node that no, this node is down, so the name node will provide the replication, and the job tracker will send the code to that particular replication, and the process will start. And then the task tracker will give the progress report again to job tracker. So this is how fault tolerance is maintained. Okay, faulty, we get the copy before the job also with the data node, during the job with the task trackers. Clear enough? Now this secondary name node guy comes in picture. What this name node does is that it stores two things. Okay, first is two, you can say, files. First is fh image, and second is edit logs. These jargons we're gonna have to remember. Okay, jargons means this name fs image. This is a file, but what is the name of the file? It is fs image. The name node maintains, let's focus on this name node. Okay, it maintains two files. Whenever we start, like I did what here, start DFS. So what, it started a name node and it started the secondary name node. Okay, so whenever we start, it creates two files, though these are empty files, totally empty. Okay, as we write this put command, then we also have one get command. Get command, the opposite, like we write this. Okay, this is let's say this was our local file and we copied it to Hadoop file system file. Okay, now we want to bring this word count again into our system. This is residing on Hadoop file system. Now we want it in our downloads. So what we do, we use the get command. So as soon as we perform a put operation, as soon as we perform a get operation, or we change the ownership of, I'm really sorry. We change the ownership of this particular file. Who is the owner of the file? Okay, we change the, so these all operations are written in edit logs. Okay, and this edit log will keep on growing. When in a typical environment, what happens is that after every 15 or 30 days, this name node will be restarted. Unless this is restarted, everything is written in this edit logs. So what it does is that when it is about to restart, it copies all this data, okay, and puts it in the FS image. Okay, so the thing is that this becomes a backup of the edit logs. Okay, now how secondary name node comes in picture? What secondary name node does is that it takes both of these and it merges them. And this is done periodically. The general period is 1 hour. In 1 hour, this secondary name node will take this. Okay, this is configurable. It depends on the administrator of Hadoop administrator, that how long will it take for the secondary name node to merge this. Okay, and when the name node, okay, and when the name node will be restarted, this secondary name node will actually give this merged image to name node and tell them that this is the point of all the storage that we have, so that it can write all that in edit logs, the new data in edit logs. And then this FS image will again is cleared, because as soon as the name node starts, it creates two empty files. It creates two empty files, but this time what it will do, first it will write the edit logs from the merge sector of the secondary name node. Okay, and keep on writing this edit logs. 1 hour goes, it will take both of these, the secondary name node and merge. Right now there is nothing in FS image, it's okay. It will take the merge, it will merge it, it will add the new things that came. Okay, and whenever the name node is started again, it will provide this merge data to the name node, and it will write the merge data in edit logs, and at the time, and backup of edit logs is what? FS image. This is how the architecture of Hadoop 1 goes. But there's a problem in this architecture. The problem is what happens if name node, if this master machine what happens if this master machine runs? So we have lost everything, right? So the problem is that name node is a single point of failure. If name node goes, we have a good chance of losing the data. The data is residing here, but the metadata, we have a good chance of losing that. So what we have to do is that whatever the operations have been performed, we cannot trace back them. We'll have to start from scratch, that where the data is residing. If we have changed the ownership, it's not going to show it. It's only going to show the new owner of this particular file, because the data node will give the as soon as the name node started, it will ask the data node that give me the information. So the information from let's say I changed the owner from Hussein to Hassan, owner of Hussein to Hassan. Of home and Hussein. This folder, I changed the owner, I made Hassan the owner of this folder. Okay, but earlier it was who? Hussein. So both of these things was stored here. Oh, sorry, both of this information was stored in the edit logs, that yeah, an operation was performed and Hussein, the owner, was changed to Hassan, the owner. But now, because the master node has failed, and we don't have any like what do we call that, change of the ownership. Okay, we don't have any earlier ownership details. What data node is going to give it? That we have the owner as Hassan. So the owner was actually never changed, the owner was only Hassan, but that is not the correct thing. Okay, so the single point of failure was a big drawback, and which was taken care by Hadoop 2, because Hadoop 2 incorporated a new guy called yarn. So Hadoop 2 architecture is also called yarn architecture. When we run this start yarn, so here we don't see any job tracker and task tracker, right? We see what? Resource manager and node managers. Resource manager is a single guy residing on the master, and node managers is what? This task. The job of the node manager is not just the task tracking, but you can say that job tracker was replaced by resource manager and task tracker was replaced by node manager. How it became better, we'll see in the next session. Okay, this session has gone really long. Okay, it is now here, I think half an hour more I've taken. So to grasp all this also, you're gonna have to need some time to understand this. So we have an understanding of what name node is, what secondary name node is, what job tracker is, data node, and task tracker. Okay, these are the kind of questions that are asked in interviews, that how Hdfs stores data, if you submit a job, how it will be taken by master and given to slaves, and all of those things. Okay, are we clear on Hadoop 1 architecture?
Yes, brother, but we have to take another flashback after later the class.
No. It is not a problem. But the thing is that I'm not saying that you grasp 100% in the class only. But the thing is that if you are not able to understand any of the part, then it is the problem. Okay. Yeah. Even if you understand like 20% of what I said right now, it's fine.
No, that's fine.
Okay. Just go through this video again. Okay. And if you don't understand anything, just message. So we can take that bit again, and I'll explain you what this architecture is doing. Okay, so I'll sign
And
off for today. Yeah.
and you give us the assignment for 3 questions, the difference between Hadoop 1 and Hadoop 2,
No,
Hadoop
I'll
block size.
see. As we have given this software folder, okay, I'm gonna make another folder here, and that is assignments.
Okay, that is
Okay, all the assignments that I'll be giving will be in this folder, and I will be actually you have this folder access, right? You have
yes,
given the access
we
to
have.
this folder, and these are the subfolders. So whenever you go in assignments, whenever I post assignment, I'll message on the group, and you will whenever
Find out the answers from by Google.
yeah, you find out the answer by Google, or if you you can find the answer from my like video also,
Lecture.
because both of these thing, small file problem I have not explained because I'll explain it when Hadoop architecture, but data locality I have. What is data locality I have actually explained in this. So when you go through the video, you'll know what data locality is, and the other questions also that I'll give. Try to do the assignments, keep it with you, write it so that you know, when you are preparing for the interview, you have in handy. You don't have to search Google again.
Okay.
Okay, so that's it for all. That's it for today. See you in the
Okay,
next
thank you,
session.
Brother Hussain.
Okay.
Recording stopped.
Okay.
Okay, have a good
Thank
night.
you.
Bye.
Yeah.
Bye.
And like, can you stay on Zoom for a few minutes, please?
হ্যাঁ
Yeah.
Only you. Rest of them, we can go, please.
আমি থাকবো
No. আপনারা যান সবাই, শুধু আমাদের ইনস্ট্রাক্টর থাকবে।
ওকে থ্যাংক ইউ